Hi and welcome to this bonus video. Today I'm going to prove the product rules. Okay, so we have 6 product rules for the gradient, for the divergence, and for the curl, 2 of each. So first I will write the product rules for gradient. Okay, so gradient will operate on on a scalar quantity f. So how we will get a scalar quantity? Taking the dot product of 2 vector, or okay, or we can simply multiply 2 scalar quantity. Let's say g and h. Okay. G and h. So first of all, we will see this first product rule. Del of g and h is equal to g times del h plus h times del g. So we will see the proof of this. Yes, so del of g times h is del by del x g h x cap plus del by del y g of h y cap plus del of del z g h z cap. So this is the simple derivative of this two scalar, and we will use the product rule. Okay, g times del of del x h plus h times del of del x g x cap plus g times del of h by del y. So in short, what we are going to have this these 3 terms. Okay, and only thing, the difference between these terms are this x is replaced by y, and then x is replaced by z. Okay, so I'm just copying this. G del h by del z plus h del g by del z z cap. Okay, yeah. So now we will take only those terms which has g as a coefficient. So this is the one, second and third. So we'll take the g common out and write del h by del x, and of course don't forget to take this x cap, y cap and z cap as well, plus this del h by del y y cap plus del h by del z z cap, and then we'll take this term which has h as a coefficient. So we'll take h common out, del by del x g x cap plus del g by del y y cap plus del g by del z z cap. Yes, so we can write like this: del by del x x cap plus del by del y y cap plus del by del z z cap, and then h will be there. So this g is multiplied with this, but this h is not multiplied with this. Okay, so we have this g, this term, right? This term, yeah, I mean this g scalar is multiplied by this operator, but this h is not multiplied by this operator, while this operator act on this h. Okay, so this is a difference between these two. Okay, so otherwise this and this term that I'm going to write is exactly the same. Okay, so if it is a multiplication, then this term and this term, these two terms are gonna same, but this is not the case, right? The thing is, this is acting on G and this is acting on H, and this H is multiplied by this operation, and G is multiplied by this operation. So we can write okay. So this is the final answer. Yes. So this is the first product rule for the gradient. Let's write the second rule. So second rule is a little bit longer. So okay, so I'm writing the second rule. So second rule comes from this the product of two I mean the dot product of two vectors. Okay, so these are same vector, but these two vectors may be different. A dot B is actually A cross del cross B. Okay, so this is the first term, plus B cross del cross A. This is the second term. Third term is A dot del operating on B plus B dot B dot del acting on A. Okay, so we have to prove this. Right. So A can be written as AX x cap plus AY y cap plus AZ z cap, right? And B can be written as B BX x cap plus BY y cap plus BZ z cap, and A dot B is AX BX plus AY BY plus AZ BZ, right? So the gradient of this A dot B is actually okay, so this is actually gonna look like this. So this is gonna acting on this dot product. Okay, so we're gonna have this first term. Okay, so let me write like this. Okay, so this is gonna acting on all of three with x cap as a direction vector. This is y, and writing the same term. Y cap del y del z, and this is gonna be z cap. Yes, so of course we will take the derivative of each of this this term, and we'll take the dot product. Okay, so I'm sorry, we'll take the product rule for each of this component. Okay, for all of three terms, right? So what we can do is just first of all name it as a first term, the second term, and then we have third term. Okay, and we will take each of the term one by one and will try to expand.